Okay, good day everyone. You're welcome once again to Master Lectures. And in today's lesson, we're going to be looking at a very interesting calculation topic under the gas laws, which is the Gay-Lussac law. All right, just as how you saw in the thumbnail, Gay-Lussac law made easy. All right, now if you are having challenges with Gay-Lussac law, all right, just stay glued and follow up every step in this lesson, and after today, after this video lesson, you will no longer be scared of Gay-Lussac law. Now let's come. What is Gay-Lussac law? Gay-Lussac law simply states that when gases react, they do so in volume. When gases react, they do so in volume, which are in simple ratio to one another and to the volume of the product if gaseous, provided temperature and pressure is kept constant. So means that for it simply means that for Gay-Lussac law, temperature and pressure are constant. All right. So for Gay-Lussac law, temperature and pressure are constant. All right. So temperature and pressure are not playing any effect. Now, Gay-Lussac law is all about comparing volumes. All right. Comparing volumes. That is Gay-Lussac law. Now, in order for you to have proper understanding about Gay-Lussac law, there is something you must know how to do, and that is writing a balanced chemical equation for a reaction. Now, as chemistry students, writing a balanced chemical equation for reactions should not be challenging to you. If you are finding it challenging, please, I want you to take out time to go and review, all right? To review it, all right? To see how you can get that, and then we'll come to the lesson, all right? However, during this lesson, we are going to see a step-by-step way of balancing chemical reaction. So in order for you to be able to answer questions on the Gay-Lussac law, you must be able to write what? A balanced chemical equation for reactions. All right? So you must be able to do that. Another thing again that you must be able to do for Gay-Lussac law, you must be able to compare accurately volume ratios. Compare accurately what? Volume ratios. So now, if you can get all of this said and done, all right, we can now start looking at examples. Now, for today's lesson, we are going to be restricting our examples to a very simple examples. All right, a very concise and simplified examples. All right, because you are just starting off. Okay, so as time goes on, we are going to look at questions that will not be based on percentage and some questions like that, where you have to leave your answers in percentage, and sometimes you just have to, maybe they'll give you a percentage and you have to get a volume of a gas in that percentage. So all those are higher areas, but for today's lesson we're going to concentrate on a simplified example. Now these examples will kick us starting, all right, it will kickstart your journey into answering questions on Gay-Lussac law. All right, now without wasting time, let's go into these questions. All right, so let's look at example one. Let's attempt example one. Now watch this. What volume of oxygen would remain after reacting 8 centimeter cube of hydrogen with 20 centimeter cube of oxygen? So now, first and foremost, remember, we must write what? Balanced chemical equation for reactions. Okay, so there are cases where you'll be giving the reaction, all right, no need to balance, you just be giving the balanced chemical equation for the reaction, while there are cases where, just like this question, you have to write the chemical equation and then balance it. So now let us write the chemical equation. Hydrogen will always and will forever react with oxygen to form water, not just water, water vapor. All right, so oxygen is a gas, hydrogen is a gas, both of them react explosively to produce water vapor, steam. They're all gases. Now hydrogen is 2 at your left hand side hydrogen is 2 at the right hand side, oxygen is 2 at the left, oxygen is just 1 at the right. So put 2 here at the front. For balance, please don't go and add 2 as a subscript. Don't add 2 below. Always put it in front. All right, 2, 3, whatever number you're adding to make the equation balance. So always add it at the front. So hydrogen here is now 4, oxygen is 2, 2, hydrogen here is now 4. So I'm going to put another 2 here. All right, now from this, main looking at this, it shows that 2 volume of hydrogen was required to react with 1 volume. Okay, you can just say 1 volume of oxygen. So now the question is, what volume of oxygen would remain after reacting 8 centimeter cube of hydrogen with 20 centimeter cube of oxygen? So we know that 2 volume, this is just a shortcut process, very easy and fast and sweet. 2 volume of hydrogen, so 2 volume of H2 required 1 volume of O2 from the balanced chemical equation. All right, so that 2 volume of oxygen required 1 volume of 2 volume of hydrogen required 1 volume of oxygen. So now 8 centimeter cube of hydrogen, so 8 volume of hydrogen will now require how many volume of oxygen? Now guess what? At this point, we will now cross multiply. So by the time we cross multiply, so what do we have? 2 times x, which is 2x, is equal to 1 times 8, that is 8. Now this point, what do? We divide both sides by what? 2. Divide both sides by 2, so that x can stand on its own. 2 cancel out 2. Therefore, x is equal to 8 divided by 2 is 4 volume. So that means 2 volume of hydrogen from the balance reaction, from the balance equation, 2 volume of hydrogen required 1 volume of oxygen. So therefore, all right, therefore 8 volume of hydrogen, okay, 8 volume of hydrogen will require what? Will require 4 volume of oxygen, like we calculated. All right, so we got 4 volume. So 8 volume of hydrogen, 8 centimeter cube, which is volume of hydrogen, required what? 4 volume of oxygen. So now, but if you look at the question, we were provided with 20 centimeter cube of oxygen. So we were provided with 20 volume of oxygen. So remember, they asked what volume of oxygen will remain. All right, that was the question. So in order to get the volume of oxygen that will remain, what do? We will say, since we were provided with 20 and what was later used to react with 8 volume of hydrogen was 4. So we say 20 minus 4. Therefore, our answer becomes what? 16 centimeter cube. All right. So the volume of oxygen remaining that remain is what? 16, which is option D. Option D becomes the answer. So now let's look at example 2. Please, at this point, if you know, if you have seen the need, all right, to pause the video, please pause the video, write down these things. All right. So I want to clean the board and solve the next question. Right, so we are going to solve the next question, which is question 2. 50 centimeter cube of hydrogen as packed with 20 centimeter cube of oxygen at 100 degrees Celsius and 1 atm. The total volume of residual gases is, so we are looking for the total volume of gases that remained. Total volume of gases that remained. So don't forget, hydrogen always reacts with oxygen to give us steam, water vapor. So by the time you balance the reaction, you're just going to get 2, 1, 2, right? That's telling that 2 volume of hydrogen reacts with 1 volume of oxygen to give us 2 volume of steam, water. So quickly, now from the question, now watch this. Because they are asking us for residual gases, all right? Residual gases. So we are going to try our best to add up the volumes of everything we can find here, all right? So first and foremost, when you are facing a question like this is what you do. Firstly, you do this. Say volume before sparking. Volume before sparking. Volume before sparking. Now what do we get? Now we are provided with 50 centimeter cube, and then we are provided with 20 centimeter cube, and then of course nothing there, because only provided with these two. It was these two that were sparked together to produce this guy. So now let's go to reactive volume. So we want to get the volume that reacted, all right? So we have 50 centimeter cube, and then we have 20 centimeter cube. All right, now ask yourself, okay, if two volume of hydrogen required 1 volume of oxygen, now how many volume of hydrogen will be consumed by 20 centimeter cube of oxygen? So how many volume of hydrogen will be consumed by 20 volume of oxygen? All right. So by the time we cross multiply, 1 times x give us x equals 2 times 20 is what? 40. So it therefore means that 40 centimeter cube of hydrogen, all right, will completely react with the entire 20 centimeter cube of oxygen, leaving nothing left for oxygen. But then if you remove 40 from 50, remember we are still having 10 left, all right? So reactive volume, so inside here 40 centimeter cube of oxygen, all right, will be removed from the 50 and react with what? 20 centimeter cube of oxygen. How do I know this? From this, I already resolved it. So 2 volume of hydrogen requires 1 volume of oxygen from the balanced equation. Then how many volume of hydrogen will be required by 20 centimeter cube, 20 volume of oxygen? So when we did that, we got 40. So 40 centimeter cube of hydrogen will completely react with 20 centimeter cube of oxygen. So now form give us 40 centimeter cube of water, basically. So volume after sparking, volume after sparking. So our volume after sparking will now be, at this point we are going to subtract 50 minus 40, 10 centimeter cube, 20 minus 20, 0 centimeter cube. So there is nothing left for oxygen. 0 minus 40, of course, anything plus or minus 0 is that same thing, all right? So we still get what? 40 centimeter cube. Now don't forget that this guy is steam, gas, all right? So now to now get the total volume of residual gases. So what are the residual gases? What are the gases that remain? 10 centimeter cube of hydrogen and 40 centimeter cube of what? Steam, gaseous water. All right. So now 10 plus 40, which is equal to what? 50 centimeter cube. So therefore, our final answer becomes 50 centimeter cube. Let's look at example 3, all right, which is the last example we're going to be looking at for today's lesson. Example 3, the very last example. Now, in the reaction above, what volume of hydrogen would be left over when 300 centimeter cube of oxygen and 1000 centimeter cube of hydrogen are exploded in a sea tube? So the key word here is we are looking for what? They've already told us what volume of hydrogen will be left over. So volume of hydrogen left over. That's what we are looking for. So the volume of hydrogen that was left over. The volume of hydrogen left over. Now let's go. Now they've already given us, you see, for this question now, we're already given a balanced chemical what now? Equation. So sometimes you might be given a balanced chemical equation, sometimes you might not be given. So just make sure you know how to write and balance chemical equations. Then if you don't know how to do it, please stay glued to this channel. I'm going to be dropping a video lesson on how you can write chemical equation and also how you can balance chemical equations. So quickly, let's go back to our question for today. Right? Now, in the reaction above, what volume of hydrogen will be left over when 300 centimeter cube of oxygen and 1000 centimeter cube of hydrogen are exploded in a seed tube? Now, we don't need to go through that kind of long method that we were doing in question 2. We don't need to go through that method because they don't ask us to find volume of residual gases. So we can bypass and use a shortcut instead of going to that long method that we did in question 2 to know the exact volume of residual gases remaining. So we can just use a shortcut for this, which is similar to the same shortcut we used in question 1. Now, watch this. So we already know that they're asking us volume of hydrogen that will be left over, right? So now, you already know from the balance equation that 2 volume of hydrogen will react, all right, or requires 1 volume of oxygen. So now, therefore, 1000 centimeter cube of hydrogen. Okay, since we are asked to look for volume of hydrogen, let's not just work with this 1000, all right? Let's work with 300 centimeter cube of hydrogen of oxygen and assume that our volume of hydrogen, we do not know it. Okay, so that we cannot know the volume of hydrogen that 300 centimeter cube can react with. All right, we now know the volume of hydrogen that 300 centimeter cube of oxygen can react with. So we now, from our answer that we are going to get, we now subtract it from 1000 and now know the volume of hydrogen that will be left over, because for the reaction we were provided with 1000 centimeter cube of hydrogen and 300 centimeter cube of oxygen. So this is what we are going to do. So now we assume that our volume of hydrogen, we do not know it. Okay, so call it X. So X volume of hydrogen will react with 300 volume of oxygen. So we want to look for the volume of hydrogen that will react with 300 centimeter cube or 300 volume of oxygen. So we cross multiply. So by the time we cross multiply, 1 times X is X, which is equal to 2 times 300. 2 times 300. 2 times 300 is what? 600. So now we have established the fact that 600 centimeter cube of hydrogen is required to react with 300 centimeter cube of oxygen. But take note, we are provided with 1000 centimeter cube of hydrogen in the question. Therefore, to now get the volume of hydrogen left over, or the volume of hydrogen in excess, what do? We now say, therefore, all right, 1000 centimeter cube of hydrogen minus 600 centimeter cube of hydrogen. And what are we going to get as a final answer? We're going to get what? 400 centimeter cube of hydrogen. So the volume of hydrogen left over is what? 400 centimeter cube of hydrogen. So that is what? Option B. So thank you very much for staying tuned to this lesson, to the end of this lesson. Please do to like, share, and subscribe. Share this video to your friends that might be having challenges with Gay-Lussac law, and I'll see you in the next video.